Solving Inequalities. Runaway pumpkin! Oh. To transform inequalities is the object of the objective. In order to solve this, we're going to solve these things just like we solved equalities that we called equations. We can call these inequations. 10-2, let's do it. Property comparison. This is called the law of trichotomy, also the property of comparison. And it just basically says for all real numbers, A and B, only one and only one can be true. Either A is less than B, A is equal to B, and A is greater than B. Okay? Or A is greater than B. Only one of these can be true of two numbers. Okay? Something can't be greater than and equal to at the same time. It's one or the other. Okay? And that gives us some interesting things. If you think about it like this, like number lines, if you have two numbers, the only following can be true. This is it. Right? So you have B right here. The only thing that can be true is either A is to the left of B, A is over there somewhere, A is right on top of B, or A is greater than B, A is to the right of B. That's it. A is either to the left of B, right on B, or to the right of B. That's it. That's the only three things that can be true, is what it's kind of saying. And what's nice is we can think about that to solve these kind of things, right? To think about these next, this transitive property, right? For all real numbers A, B, and C, if A is to the left of B, so let's do this, ready? If small a, if A is to the left of B, so I'll put B to the right of it, right? And suppose B was to the left of C. Oh. Then we can say A must be to the left of C. Yeah. You know, if A is less than B, B is less than C, then of course A is less than C, right? This is 2, this is 5, 5 over 6, okay? But think about it, graphically, it kind of shows it there too. Another way you could say it, same thing. If C is greater than B, well, C is to the right of B. And if B is to the right of A, B is to the right of A, then obviously C must be to the right of A, way to the right of A. Yeah, of course, man. We did this transitive property before with equalities, and it looked like this. Ready? It says, if A equals B and B equals C, then A equals C, right? If A is on top of B, and if A and B are in the same spot, B and C are in the same spot, then A and C must be in the same spot. All right, anyway, the addition property of order. Suppose A is to the left of B, or A is less than B. Then adding C to both, suppose I add some distance C, right? I add C here, I add C here. These are still going to be the same thing. Adding C to A, moving A a distance C, let's say we add C to it, we're going to end up right here. And B a distance, the same distance C. A plus C is still going to be to the left of B plus C. Think about it. If you know that 4 is less than 8, you add the same things, you add 10 to both sides, 14 of course is going to be less than 18, because you're sliding these together the same distance on the number line, so whatever you add to it, this guy's still going to be to the left of this guy. And the other way around, obviously, if B is greater than A, if A is greater than B, A is greater than B, you're still going to slide these guys the same distance. You think about it as adding C to both, the same amount, is you're sliding them both on the number line together, so they're still going to be relative to each other. The new sum is going to be greater than this sum, right? All right. Now let's see what happens when we multiply things. Now here's kind of hard because we're going to be stretching things out. So it's good to look at some examples, some real number examples. So let's do it. Let's multiply both sides by 2, 3, 5, and 0, see what happens. Here we're going to multiply both by, so we know, we're saying it's starting off true. This inequality is true. Let's see if it stays true, right? I multiply both sides by 2. I get 8, 10. Is that still true? Yeah. What about this? Multiply both sides by 2. I get 0. Is 0 greater than negative 4? Yeah. Let's see. Negative 5 is less than negative 2. Is negative 10 less than negative 4? Yeah. Negative 2 and 8. Is negative 4 less than 16? Yeah. So multiplying by 2, everything stays true. Everything's still true. So that's neat. Let's see when I multiply by 3. Is 12 less than 15? Yeah. Is 0 greater than negative 6? Yeah. Is negative 15 less than negative 6? Yeah, it's small. Then it's to the left of negative 6. And is negative 6 to the left of 8 times 3 is 24? Yeah, negative 6 is way to the left of 24. What about 5? The same thing's going to happen. You get 20, 25? Yes, to the 20 is left of the 25. 0 is definitely to the right of negative 10, right? Let's see, negative 5. Negative 25, is that still to the left of negative 10? Yeah, it's further down to the left of negative 10. And is negative 10 to the left of 40? Yeah, negative 10 is on one side, of the left side of the thing. Now what happens if I multiply both sides by 0? Is 0 less than 0? No. Is 0 greater than 0? No. Is 0 less than 0? No. Is 0 less than 0? So what happens here is I'm multiplying both sides. Remember we said you can multiply both sides? As long as you do the same thing in an equation to both sides, you're all set? Well, here it's not quite the same. I mean, yeah, when you're multiplying by these positive numbers, it stays equal, so you can multiply both sides by positive numbers. But when you start multiplying by 0, it's not true anymore. When you multiply by 0, you end up with an identity, not an inequality. You end up with an equality, okay? So what you can do in this is the rules change a little bit. Now look what happens when you multiply by negative 1. Let's see. I have 2 right here, right? 2. We know 2 is to the left of 4, right? Here's 2. Here's 4. I'm going to multiply both sides by negative 1, or taking the opposite. Now what happens? Where does 2 go? Let's see. I'll think of it as a transformation. I multiply them both by negative 1. I end up with negative 2, negative 4. Let's see if this is still true. Let's go, this guy goes to here, flips across, negative 2, here's negative 4. Let's see. Is negative 2 to the left of negative? No. Negative 2 is not. This is not true. I can't multiply both sides by negative 1 and still have and still be true. What happens? When I flipped it over like this, when I flipped it across, that sign here should flip with it, because now I'm taking the opposites. Notice what happens here. Obviously, negative 3 is to the left of 2. Negative 3 is to the left of 2, is less than 2. When I take the opposite of both, when I take the opposite of negative 3, I get 3. This guy goes. When I take the opposite of 2, I get negative 2. This guy goes. They both switch sides. Whoa! So the whole thing flips. So when you flip that whole thing, take the opposite of everything, you need to also take the opposite of that sign. You have to flip the sign with it. So you have this. To keep it true. To keep it true, you need to make the sign go in the opposite direction. So when you're multiplying both sides by the opposite, or negative 1, when you're taking the opposite of both sides, if you're multiplying both sides by any negative number, you have to switch the sign. So here we go, quickly. Here are the rules. When C is positive, if A is less than B, then then you can multiply both sides by a constant. And it's still going to be true. Watch. Multiply both sides by, when C is positive, ready? 5 times 2 is 10. 2 times 2 is 4. Still true. But when C is negative, what do you have to do? If you multiply both sides, look what happens to the sign. Got to switch it. Got to switch the direction. So when you multiply both sides by a negative number, switch that sign. Okay? So pretty much do all the same things, but when we're solving equations. But when you multiply or divide, because you know they're inverse operations, by a negative number, you have to reverse the direction of the sign. Don't forget to reverse. That's the main difference here. Okay? Let's solve a problem here. One's going to be pain. Well, let's do it anyway. All right. Let's multiply both sides by 4 to get rid of these fractions. So I get 4n minus 10 is greater than 3n minus 6. I get 4n minus 10 is greater than 3n minus 18. I want to get the n's all alone on one side, so I'm going to subtract 3n from both sides. I get n minus 10 greater than negative 18. I'm going to add 10 to both sides. I'm going to get n is greater than negative 8. To graph that, I go down from 0 down to negative 8. I put an open circle on it, and I know n is going to be greater than it, so it's going to be to the right of it. Because it's going to be to the right of it, I do that and leave an open circle. Now watch, if I solved it another way, I don't have enough time. But either way, if I was to have to multiply or divide by a negative, like if I got at this step, if I, instead of subtracting 3n, I subtracted 4n, I'd have to switch the sign, you get the same solution. Try that at home. All right? Have a nice day.